Today we're looking at lesson 3.2, which is on angles and parallel lines for geometry. So there's several postulates and theorems in this lesson that I'm going to indicate, and we're also going to have to use for our explanation. So this is the first one that they've indicated, and that's corresponding angles postulate. So if you have a diagram that looks like this, that the one I've pictured here, where you have two parallel lines that are cut by a transversal. So you can see they're parallel by the little pink triangles on them, and they're cut by what we call a transversal, which is a straight line through them. Then each pair of corresponding angles is congruent. So they've listed the corresponding angles. They've also put those as in red. So they have here, the examples are 1 and 3, and notice the positions of them, and then 2 and 4, as well as 5 and 7, and 6 and 8. So there's 4 pairs here of corresponding angles. So here's our diagram that we're going to use, and we need to find the angle measures, and they're going to give us some information here. So it says, suppose angle 8 is 105. So if we go back, that means right here is 105. And with that, we need to find the measure of each angle on the next page here. So, and we're also going to tell the postulate or theorem that we used. So angle 1, we go back to our diagram. Angle 1, it looks like, is in the corresponding angles position, so that it would be congruent to angle 8. So that would be 105 as well. And since it was in the corresponding angles position, we're going to use postulate 3.1, or the corresponding angles postulate. Now the next angle we need to find is angle 2. So if we know that angle 1 is 105, angle 2, they make up a linear pair, or you can talk about this with the supplement theorem, which we've already learned in the last chapter, which means that a linear pair will add up to 180. So if we have 105 for angle 1, that means if we subtract that from 180, we'll get 75 for angle 2. So angle 2 is going to be 75. And we're using theorem 2.3, which is the supplement theorem, which basically states that if you have a linear pair, the two angles would be supplementary. And then angle 3, if you go either to look at angle 2 and 3's relationship, which would also be theorem 2.3 or the supplement theorem, you could also determine that it's 105, or you could look across from angle 3 at angle 1, which those are vertical angles. So you would actually be using either the vertical angle theorem for your explanation and to make that 105, or the supplement theorem. And you could list either one. I'll list the vertical angle theorem since we already used theorem 2.3. Now we're given we're given a few more theorems here, and these are called, again, based on parallel lines and the transversal cut in between it. We have alternate interior, which they've listed here in blue and red for theorem 3.1. That's basically what it says, is it's the interior of these two parallel lines, and they alternate between the transversal. So angles 1 and 3, and 2 and 4. And then consecutive interior angles, those are, again, inside the two parallel lines, but they are next to each other, so that means consecutive. 1 and 2 would be consecutive interior, and 4 and 3 would be consecutive interior. And those are not congruent, those are supplementary. And then you have the alternate exterior angles, and that means they are outside of the two parallel lines, and again they alternate between the transversal, so angles 5 and 7 and 6 and 8, and those are also congruent. So here's another diagram, and it gives us angle 1 is 100, and we need to find angle 4, and if you look there, 1 is inside the parallel lines and 4 is outside the parallel lines. So if we look at our theorems, there's actually not a specific theorem that tells us how to find angle 4 with just 100, but we can use 100 to find another angle, angle 2, and then angle 2 we can use to find angle 4 because those would be the supplement theorem because those are forming a linear pair. So angles 1 and 2, if you notice, they're inside the parallel line, so they're going to be interior, and they alternate on Park Road, which is the transversal, so that makes them congruent. So that makes angle 2 also 100. Now if we have angle 2 as 100 and we're finding angle 4, then those two would be supplementary because of the supplement theorem, and they form a linear pair, so that makes angle 4 80. So we would use both the supplement theorem and the alternate interior theorem. Now, if we start over with a new set of data, it gives us another example here with angle 3 being 70. So that's here. And we need to find angle 4 again. So angle 3 and angle 4, notice those two are alternating between Park Road, which is the transversal, and they are actually both outside of the parallel lines, which makes the angle 4 also 70. And that's by the alternate exterior angle theorem. Now we have another diagram here, and again notice the parallel lines J and K cut by the transversal L. So it gives us that angle 2 is 4x plus 7. And angle 7 is 5x minus 13. And notice those two are both outside of the two parallel lines, J and K, and they alternate on the transversal L, so that makes them equal. Alternate exterior angles would be equal. So if we're going to solve for x, we need to put this equal to each other. So 4x plus 7 equals 5x minus 13. So x would be 20. And now the same idea with a diagram. It gives us angle 5 is 68 and angle 3 is 3y minus 2. Actually, I said that was 3y minus 2. So again, look at 3 and 5. Now 3 and 5 are on the interior of the parallel lines, and they are next to each other. So that's the actual consecutive interior theorem, which actually says that they are supplementary. So we're going to solve for y by putting them equal to 180. So adding them up and putting them equal to 180. And we get y is 38. And then this is also thrown in here, but we're not using this in a particular example. It's just telling you that if you have two parallel lines cut by a transversal that's perpendicular, that makes both of those lines perpendicular to that transversal, or 90-degree angles. And that concludes lesson 3.2 for geometry on angles and parallel lines.